Hi, my name is Michael Champlin. I'm going to be providing my example from written homework number 1, problem number 5, which is an example of differential equations involving an integral function. Let me start by reading the actual question, which is find an explicit solution of the given initial value problem in terms of an integral function using the techniques shown in class. Please show all work. So what the question provides is, first off, that y at -2 equals 1/3, which this would be x and y, just to let know. And then over here, they provide the differential equation of dy over dx equals y squared sine to the x cubed. And I also prefer to put parentheses around x cubed so I don't get my variables mixed up when I'm using sine or cosine or anything trig. So where do you start? Well, first, you can look. This is a problem that's pretty comparable to separate the variables. So you could bring the y, you could divide y on both sides, so then you would get y over 1 over y squared, and then you can multiply by dx on each side, so you'd get, so the dy would stay, then you'd have sine x cubed to the dx, because again you're multiplying dx over here and you're dividing by y throughout. So now that works excellent because you have both your x's on the right side and both your y's on the left side. So from there, it's comparable to integrate. So I like to do in separate colors that we can integrate. Now if you look, the left side isn't too bad to integrate. I personally prefer to look, when I integrate 1 over y squared, I like to make it y at the -2 because it's a little easier for me to represent it that way. Which then for the integration, it comes down to so you're going to add 1, so it's y to the -1, and then it'd be 1 over -1, which would just equal -y. And then you have, since we're integrating both sides, I'm not going to put a constant yet. Now, if we look at the integration of sine x cubed, that one's a little tricky because you can't integrate that directly. You need to have an x squared outside of it to divide if you want to use something. So you have to integrate from the initial x coordinate, which your initial x coordinate would be -2. Thus, you're going to want to put the integral from -2 to x. However, now your variable is over here, so you have to put in a dummy variable or a variable to place so you can focus on x in the end. So then you're going to, I like to use t, so you're going to provide sine t to the third dt, because now we're deriving from dt, and then you can also provide your constant, so you don't want to forget your constant, because overall we're going to initially be deriving for x. You're not totally getting rid of x, but you're putting a new integration function in. So where we're at now, which is awesome, we can solve for y, which you're going to bring, I prefer to bring the 1 because it's negative, so because of the exponent, it can be -1 over y, which equals integral c. And then for your general solution, you get y equals, now just flip over because it's multiplying by a fraction, equals -1 over the constant plus the integral -2 x sine t to the 3 plus c. And that right there is your general solution. It's great that now we have discovered the general solution. However, the question is asking us to find y of negative 2 equals 3. So whenever you see this, first off, always remember this is the coordinates of negative 2 to 1/3. It always helps me to remember how to set it up. So if we're going to set this up, we need to plug these into the general solution. So therefore, your y is going to be 1/3 equals negative 1 over c stays plus the integral. Oops. So we have to substitute in x. So the integral of negative 2 to negative 2 sine t remains to the 3/3 and dt. All right. So the first thing you need to recognize is with the integration, you have a function going to a function. So in other words, if you look, you have f of negative 2 subtracting f of negative 2, which equals 0. So now knowing that, we need to find c so we can go back and find a particular solution. So now we have to solve for c, which now that we know that this integration equals 0 because of f of negative 2 to f of negative 2 equals 0, we can show that 1/3 equals negative 1 over c. And with some cross multiplication, you actually get c equals negative 3. So we found c. Now that we found c equals negative 3 in regards of y negative 2 equals 1/3, all we have to do is substitute negative 3 into the general solution to get to the particular solution, which you get negative 1 over negative 3 plus the integration of 2 to the x sine t to the 3rd dt. And that right there is your particular solution and the solution to the problem. You can go back and check. There's excellent videos on lectures number 6 in Unit 1 that provide even further in depth. But I hope this helped. And fair warning, I have not got my grades back for this homework, so there could technically be errors. But nonetheless, I hope you guys have a great day, and thank you very much.